And that should do it. So we're ready. Hello guys, welcome to another video. Today I'm going to answer a question and make an experiment at the same time. Many people have asked me if they can connect two brushless motors into one ESC, and I always have the same answer: no. You shouldn't do it because it wouldn't work. That's based on the theory, but what happens on practice? I mean, in real life, I don't know if that will work because I haven't tested it yet, but I want to see what happens, what other weird things we will see while this is going to happen. So today I'm going to show you why this shouldn't be done in a configuration for your RC airplane when you have two or more brushless motors. So here on my workbench I have two brushless motors. I connected the three set of wires that each have to the other three set of wires that the other have, and then I connected these three inputs that are going to be connected to an ESC or electronic speed controller. So this is made to be connected to three set of wires to control one brushless motor, not two. We will see why this wouldn't work, but I certainly know that this won't work very good. Now, that's the theory. I haven't run the experiment yet, so we will see if that happens in real life when we connect and run the experiment right now. So let's do that.
Brushless motors work with a set of magnets and copper coils wrapped in iron cores. In an hour-runner motor, which is the type of motor we're going to see today, the magnets are attached to an external rotor, and the coils form the stator on the inside. The coils are separated by phases and poles. To turn the motor, we must change the voltage in the coils in a specific pattern. This pattern is generated by an ESC or electronic speed controller. This device has the task of sending the signals to the motor to make it turn and also to control its speed. In each phase change, two phases are active and one remains disconnected. The phase that remains disconnected is used to capture the magnetic force of a magnet, and in this way, the ESC, when receiving this signal, will know when to change the next phase at the precise moment. This happens hundreds of times per second, depending on the speed of the motor. If we add another motor to this system, many problems might occur due to the nature of the operation of this system, depending on synchronization. For example, if one of the motors for some reason is not synchronized, will generate corrupt signals that the ESC is going to detect as an error, stopping both motors. And that's the main reason why the functionality of two motors connected to a single speed controller is very doubtful. But that's a theory. Let's see what happens in the experiment. So here I'm setting up all the connections with the two motors, and I'm going to connect these wires to this ESC, and here I'm using a servo tester to control the speed of the ESC. I'm also going to use a 3-cell battery for this experiment. Another interesting thing I noticed is that I can transfer the energy when I rotate one of the motors, so the other one starts to shake because of the fluctuation of the voltage produced by the other motor. So here we go with the first test. And that's quite impressive. Both work without any problem, or that's what it seems. But actually, each motor is not working at its full potential. That's one of the reasons why you should avoid using one ESC. Now I want to see what happens when I stop one motor. I will use a brush to do that. I don't want to hurt myself. And as you can see, when I stop one motor, the other also stops. And that happens because of the theory we talked earlier. The ESC is detecting the signal of the timing of one of the motors at the same time as running the other, but there is an error because one of the motors is stopped, so the ESC is just seeing one motor, and because there is this error, it decides to stop. So this is clearly not a good idea if you want to use this configuration for an airplane. If one of the motors stops for one reason, the other will stop as well, and that's not a good sign. But even if you manage to go without any problem, there is a problem of the efficiency because both motors will have to consume the same amount of amps through the same ESC. So that ESC have to be twice the capacity of one motor. So for example, if you're using two motors of 30 amps each, then you will have to use at least a 65 amps ESC. The motors that I'm using right now are capable of reaching 25 amps each, and the ESC that I'm using is 30 amps maximum. So there is a huge gap there, and also the ESC is right now getting a little bit hot, but because I'm not pushing it to the limit, it's not gonna be a problem. But I still recommend one ESC per motor because if one motor fails, then the other still works. Now I'm going to use two different motors. I'm going to use a bigger one with different characteristics of the other, and we will see how they behave. And it doesn't work. These two motors are very different. Even the numbers of poles and magnets are different between each other, and also the sizes and the impedance of each motor. So there is a bunch of problems that the ESC is detecting, and that's why it's not working at all. Now I'm going to use another motor similar to the one that I'm using right now, but different brand. And let's see what happens. Both motors are 2205 in size and has the same number of poles and same number of magnets, but they are a little different in the way they perform. So let's see what happens. And there you have it. Both motors are connected, but only one works. There might also be a problem of the wiring. But even changing the wiring, only one motor will work. There is a lot more going on in the background, like scientific stuff and mathematics that I'm not going to explain and I don't even understand, so let's skip that. But the result is that two different motors of different characteristics won't work when you connect them to a single ESC. So that's almost impossible. And when you connect two motors of the same brand, same characteristics to a single ESC, then they work, but it's not recommended.
So as you could see, it is not a good idea to use two brushless motors connected to one ESC. As you saw in these experiments, there are a lot of reasons why. First of all, even if you're using two motors of the same brand and same characteristics that they seem to work well, they are not working as good as they should work. They're not efficient enough when you're powering two brushless motors from the same ESC. Also, there is more risk of a failure if the ESC breaks, or even if you stop one brushless motor for some reason, one brushless motor stops working, the other won't work, will stop working because they depend from the same ESC. So that's not a good idea. And when you're using two different brushless motors in terms of characteristics and sizes and whatever, they don't work properly. So it is never a good idea to use the same ESC to two different brushless motors, or even more if you're crazy enough to try that. But I hope you liked this video and it answered that question. If you did like this video, please just click the like button and consider subscribing if you want to see more videos like this in the future, and maybe press the bell button. Well, for now, I hope to see you in the next project.